So the next is about dynamic array. The next is about your dynamic array. Please be little bit careful over here. So dynamic array means that is the array is going to be allocated at execution time. The array is going to be allocated at execution time. That is known as your dynamic array. So here what is required here? So the advantages of using a dynamic array is wastage could be avoided, insufficiency may not arise. Wastage could be avoided means only based on the requirements, when and how, when the execution is taking place, at that time only your array is getting allotted. So what happens is the needs and requirements according to the execution only your array is getting allotted. So only so many number of locations are being used. Insufficiency may not arise. Insufficiency may not arise means since you are using only the required amount, we are not going for excess amount. Like in your static array, already first itself we are declaring the array and keeping, that is a size. And after that, if you are not using the entire size, means what happens? The array gets wasted. The array, the remaining portion gets wasted. So what happens? Because of this wastage, the accumulation, what happens? Insufficiency might arise in your static array. Insufficiency might arise in your static array. So here what is it? You're using it as and when it is required. So wastage is not there. Insufficiency will not also arise. So now how to go on to declare your arrays? So here the syntax, data type, first it should be declared as a pointer variable. Data type, first it should be declared as a pointer variable. That is, we have seen how to go on for a dynamic allocation of a simple variable. Only thing is here we are going for along with your concept of arrays also. So first it should be declared as a pointer variable. After declaring it as a pointer variable, that pointer variable is equal to new. New is your operator to indicate that it is your dynamic array, that is with dynamic memory location, memory allocation. Data type, and then data type, and then what is the size? Size is to be given only inside your square brackets. Size is to be given only inside your square brackets. So this is the general syntax for declaring your dynamic array. So the allocated array should also be allocated with the delete operator. The allocated array should also be allocated with the deallocated with the delete operator. As I have told you, that is in your dynamic memory allocation, every single pointer variable. Now we are using the concept of arrays also. So every single array that is allocated dynamically should also be deallocated with the help of your delete operator. That is a must. Okay. So how it is getting deleted? How it is getting deleted? So this is the statement for deleting your. This is the statement for deleting your deallocation of your memory, deallocation of your array, that is delete. Now listen here, listen to this point very carefully. Delete, then we normally give it as open size. We normally give it as open size. Why did I give it as open size? Why did I give it as open size? Listen to the explanation. Why did I keep it as open size? For example, if I have given the size as 10, if I have given the size as 10, by mistake, I gave you only the size allotted is 10. Size is 10, you assume. But by mistake, I gave it as delete. 9 alone I have given, and then the pointer variable, for example, if it is ptr, I have given like this, means what happens is one array location is still remaining as used in the memory. One array location is still remaining used in the memory. It is not deallocated. It is not deallocated. So to avoid this confusion, we keep it as, unsized. We keep it as unsized. That is, simply we give it only the square brackets. That is, simply we give only the square brackets, which means that any amount of array that is allocated, will be automatically deallocated. Any amount of array size that is allocated will automatically be deallocated. That is the meaning. So this is an advantageous way or the best way to deallocate your array. This is the best way to deallocate your array, because if you go on to give the size, you should be very careful in giving the size. That is 10 if it is the size. So you should also give it as 10. By mistake, if you make it as 9, what happens? One memory portion is still not deallocated. So to avoid that confusion, what we do is we go on to use it as unsized array. So what happens? Every amount of array that is created, that is allocated, will be deallocated. Is this part clear? Is this part clear?
Yeah.
Okay. So size can be a constant, a variable, or an integer expression. A size can be constant or variable or an integer expression. Now look into the example. Int star ptr is equal to new int of 10. Int star ptr is equal to new int of 10. Int star ptr is equal to new int of 10. Now listen to these statements very carefully from here onwards. Two different statements are available. Please be very careful. Int star ptr is equal to new int of 10. That is inside a round brackets. Listen carefully. Inside a round brackets you are there, which means that a value is initialized, okay. Value of 10 is initialized. Okay. Now look into the next statement. Now look into the bottom of the screen. That is int star ptr is equal to new int of 10. Int star ptr is equal to new int of 10. 10 I have given it inside a square brackets. So which means that PTR is a dynamic array, of size 10, which means that PTR is a dynamic array of size 10. Is this part clear for you? So this is a sure 1 mark question always which comes. These two statements will be given. They'll give you, the question is, what is the difference between these two statements? So the answer for this is, for the first one, initializes the value of 10 to the pointer variable ptr, and for the second one, initializes the pointer array of size 10. So clearly you should specify the answers. Is it clear? So next topic here is pointer and string. Next topic here is pointer and string. So here your string, when we use, it has got lots of advantages when doing along with your pointers. When going along with pointers, it has got so many advantages, and it's easy to write a program with string and pointers than compared to using your static variables and static arrays. Okay. So string data means what you have learned. It is a character array. Directly string as a variable or, or as a data type. String as a data type. We don't have it in a C++. So what we do, we go on with character array. We go on with character array. So that array name can also be considered as a string variable. Can array name be considered as a string variable? Yes. Yes. That is, in our 11th standard, we have learned in our 11th standard, we have learned character str of 10. If we have declared, we can simply give in as C in str. Like this, we were able to give a statement, right? So it becomes your string variable. We were able to consider like this. So now always here str contains the base address. Str contains the base address. Now just previously we learned in the concept of pointers and arrays that any array that is any pointer variable, any variable will always contains the base address. Any variable will always contains the base address. So that base address, that variable also can be considered as a pointer. That can be considered as a pointer. So character occupies only 1 byte in the memory. See, with this point only, we are going to learn about how character pointer differs from other pointers. With this point as the main segment, we are going to learn how your character pointer differs from ordinary other pointer. Other pointer means your integer pointer or a float pointer. Okay, that is the meaning here. Character occupies only 1 byte in the memory. Character occupies only 1 byte in the memory. So for example, if we have learned, for example, if we have that is in your when your character array is taken, we have learned the partitions to be like this. Yes or no? We have the partitions to be like this, where each cell has got only 1 byte, where each cell has got only 1 byte. So based on this only, how it is going to move and all, you are going to learn. How it is going to differ, you are going to learn. Is it clear? So first we'll learn each and every segment. Now listen to the statements. Character. First I'll put off all the contents here and then I'll go on to explain. Now first statement, you listen. One by one, whatever I underline, please listen, okay? Character str is equal to 20. Character str is equal to 20. This is the declaration statement that we have learnt in a +1. This is the declaration statement that we have learnt in a +1, which means a character array is declared, which means a character array is declared. Okay. Now, when we are going with pointers, we need not make use of this array itself. We need not make use of this array itself. Why? Because character occupies only 1 byte in the memory. Character occupies only 1 byte in the memory. So character star sp if I give, character star sp if I give. The reason why I tell over here is, for example, if this is your location, array means you have only 1 byte for each location. You have only 1 byte for each and every location. That is, this cell has got only 1 byte. This cell has got only 1 byte. Every single cell has got only 1 byte. Every single cell has got only 1 byte. So that is why we are moving it as a single variable itself, single pointer variable itself. So character star sp. So C in str, you were able to do it in C++, yes or no? C in str, you were able to do it in C++, that is in your +1. Because your character array can be considered as a single string variable. A character array can be considered as a single string variable. So with this, we were able to give the example as program. Or any single string, you can give it as input. Any single string, you can give it as input. So now for this example, now for you to explain this example, I am taking the word or string known as program. Word or string known as program, I am taking it. Is it clear? So simply cout str also, that also we have learned in +1. This statement also we have learned in +1, which displays the output as program. Which displays the output as program. Is this part clear? This is what you have learned in your +1. Now the difference, specialization you are going to learn. Now the specialization you are going to learn. So we know that SP is a pointer variable. SP is a pointer variable. SP is a pointer variable, and str is an ordinary static array. Is an ordinary static array. Is a valid statements in pointers. That is a this part of your characters is very much valid, but this is not 100% valid when we move on with your numerics. Okay, why? Because characters occupies only 1 byte in the memory. Characters occupies only 1 byte in the memory. So SP is equal to str. This statement is a valid statement, which means contents of str is copied to SP, which means contents of str is copied to SP. This in normal C++ program, it could be done only with the help of your string copy function. That is, the contents from one string to another string can be done, that is copied, could be done only with the help of your string copy function. But this is a specialization part of your character pointer. This is a specialization part of your character pointer. That is, the contents from one string can be directly assigned to another character pointer variable. Understand the points clearly? The contents from one string can be copied to another character pointer variable. So this is the statement. So this is the statement. So the contents from one string can be copied to another character pointer variable, means this is the statement. So this is one specialization of your pointer variable. So whereas in your ordinary character variable or in an ordinary array, that is directly not possible. It is possible only with your string copy function. So this is a specialization in your character pointer. Is it clear now? Now the next part you see. Now the next part you see. Next statement. Cout SP. Cout SP. SP, I told you the contents from str is copied to SP. So what happens? So cout, if I tell, what happens there again? The content that is there in SP is coming out as your output. So the answer for this is program. The answer for this is program. Is it clear? Cout SP means the content that is stored in SP is coming out as your output. So that is your string known as your program. Now shall we move on to the next specialization? Now cout ampersand str. Cout ampersand str of 0. Cout ampersand str of 0. Listen, str is an ordinary variable. Str is an ordinary static variable. You are trying to display the address. Actually, ampersand means it is address. But in your strings, this is a specialization. Where it will actually display the entire content. That is ampersand str of 0. If I give, the entire content will only be displayed. That is, program will only be displayed. This is a specialization. Okay. If we access the address of string data, we get only the string itself. That is the answer. Why I get this answer is, here we cannot go on to directly access the address of any string data. Whenever we try to access the address of string data, we will get the string only as the answer. We will not get the direct address value as the answer. We will get only the string as the answer. This is the another specialization of your pointers. Is it clear? The next, Cout SP plus 1 displays the string program. Cout SP plus 1 displays the string program. Why Cout SP plus 1 displays the string program? ROGRAM? Because SP from the first position only. That is, SP means P also will be included. Plus 1 means from the next position in the array. From that position only the contents are extracted. That is, plus 1 position means, so from the second position of your array only the contents are extracted for you. That is why the letter P is left out. And only from the second letter you're getting the answer. That is why ROGRAM is coming out as your answer. Okay, here the pointed arithmetic also follows. Pointed arithmetic means increment plus 1 position. 1 position means here indicates 1 byte only is occupied by your characters. So it is immediately moving on to the next location. That is why you get the answer as ROGRAM. Okay. So if it is ampersand str plus 1, I told you that is a specialization of your characters over here with arrays. That is, here if you try to get the address, you will not get the address value. Instead, you will be getting only the string as the answer. That is why, leaving out the first letter, the remaining letters you're getting as the answer. Leaving out the first letter, you're getting the remaining letters as the answer. So can you tell me what it could be for SP plus 2? For SP plus 2, your answer will be, R also will be left out. Your answer will be OGRAM. OGRAM will be the answer. If it is ampersand str plus 2, here also the same answer. OGRAM will be the answer. Is it clear? So like this, you can pass on till the end of the array. Now, str of 0. That is, str is your array. What is the content stored in str? That is P. That is the letter P in your static array. Star SP means also displays the letter P. Also, listen, star SP means it is a pointer variable. Star SP means it is a pointer variable pointing to the first location. So that is how you get the answer as P over here. So these are the simple specializations you will be learning about with the character